Everybody, this is Larry. This is me going over Q4 of the weekly contest 210. Count subtrees with max distance between cities. Hit the like button, hit the subscribe button, join me on Discord. So I was able to solve this in about 12 to 13 minutes during the contest or during the virtual contest, which is sad. I think one thing to note this is that there's a lot of things to read. I think that's the easiest observation. So I wasn't sure, so I took a look at the example, but subtree was a little bit confusing. Well, maybe not, but then when I look at here, the explanation was actually pretty good. I was like, okay, subtree, so that means that there's some, some combinations there, and I was like, that's gonna be a little bit like at this point I was thinking about some sort of recursion type thing, and some kind of running count with max distance, and then luckily when I looked down I saw n is equal to 15. Sometimes I miss it, right, or at least miss it until like later on, but this time I saw it early. Sometimes I don't know why it took me so long, but so n is equal to 15. That I was like, okay, then it becomes easy. Maybe not easy because it's hard to say something is easy when a lot of people had trouble with this one, but it became components that I was able to figure out, because, well, the first thing that happens is that when I see n is equal to 15, I go, well, can I brute force 2 to the 15, something like that, right? And then the answer is yes, because when you have, when you take a subtree, on one of the 2 to the 15 possibilities, that describes, it may not describe a tree, but it may describe a subset of nodes that we're trying to figure out, the max distance. And the max distance, if you recognize, is also just the diameter of a tree, which is something that I've solved on stream before as well. But definitely Google it. It is a little bit of a prerequisite, and also it's kind of annoying, I would say, because if you didn't know that, or if you're not familiar with the diameter of a tree, you're probably not going to solve this. Maybe you could Google it, but like during the contest, but in general, it makes it harder, right? But once you know that, then it becomes straightforward. It becomes an implementation problem, because you just have brute force, backtracking or whatever, on 2 to 15, and then for each of those nodes, each of those subtrees or possible subtrees, it becomes a max diameter problem, or diameter of a tree problem. And if you know the literature, you could find the diameter of a tree in of n times, right? And then when you kind of put everything together, you could do stuff roughly in n squared to the n time, and it'll be fast enough. And we'll go over my implementation after noting that. And you can watch me solve this live. I did it pretty quickly. I had a couple of off by ones because I didn't notice that these were one index until later on. And I also had and I also returned the index in the D in a silly way, because I was just also off by 1. So that said, if I solved it in 13 minutes, including the off by 1s, I feel pretty good about it. I don't know, right? But yeah. So now, So now that I book in the problem solving into multiple components, this is what. How I'm going to go through it, right? Which is that for each mask of this tree, which means for each version of this tree, I put in a list. You could do it in a number of ways. I wasn't really consistent about it. And then this just gets the diameter of a tree. And then for each diameter of the tree, we increment it from D, right? And this is just the results they ask you, which is, count the number of elements for each length. And then, that's it, right? And then this gets the diameter of a tree. Naming is terrible during competitive programming, but that's the possible diameter of the tree. And this is a well-known algorithm, so I'm not going to go over it too much. It's very Googleable. But basically the short TLDR idea behind the diameter of a tree is that you could take any node on a tree, you do a depth first search to find the farthest node, and then you do that again, meaning the farthest node, you take that node, you do a depth first search to find a node that's farthest from that node, and then that will give you the diameter of the tree. And there are proofs and stuff like that. I'm going to skip that because you'll have to do your research on that one. But basically, that's about how my code works. Essentially, I take the first node, I do a depth first search to find the farthest node, and I do this thing that is that if all the nodes are not visited, then return -1 because then it's not connected, it's not a tree. So I just return -1. Yeah. And then again, if we are able to visit all the nodes, then we take the previous farthest and then we do a depth first search again. That's pretty much it. And this depth first search is pretty standard around tree depth first search, and just making sure that it doesn't loop and all that stuff by checking its parents and stuff like that. So yeah, so I was able to do this very quickly because I did recognize the n equals 15-bit. I think that for me, that's the key observation. The other stuff is a little bit more about knowledge and trivia, in which if you don't have to prereq, you don't have to prereq. I think it's just something to study about. But yeah, but that's all I have for this problem. Let me know what you think. And watch me solve this live next. Oh yeah, going over the complexity of this algorithm. So I forgot to go over the bit mask a bit. So this is a bit mask way of doing exhaustive checking every possibilities. You can also have done this with backtracking, in which you make sure that it's a connected graph and stuff like that holds. But the way that I have learned from competitive programming mostly is that I just do this with a bit mask. And what is a bit mask? Well, bit mask is that this thing which will count from 1 to 2 to the n minus 1, right? So basically, this counts from something like, binary. I'm just writing a binary number. So to this, right? And the reason why I started at 1 is so that I don't have to start at 0, because if we don't count the case where there's no nodes in the subtree. That's the reason. But now we start with 1 and we go to 2 to the n minus 1. Then for each of these, so we go for every possibility. And that when we get to line 54, 55, you have some like binary string, right? Oops, that's 4 is not a binary number, in case you're wondering. And what does this mean, right? So we do a for loop. So position 1, that means vertex 1 is 1. So that means that vertex 1 is in the subtree, right? So that's basically what we're doing. And then we have a 0 in this case. Vertex 2 is a 0, so that means that vertex 2 is not in the subtree. So basically, what we're doing here is just doing every possible case, which is the exhaustive search part. Yeah. So then now you may ask, what is the complexity of this problem? Because I skipped it. That's my bad. So in terms of time, as we mentioned, this is going to go up to 2 to the n. So 2 to the n is the number of loops. You can see that we already do at least O of n work, and we're gonna calculate. I'll go over the complexity of this first, but for now, let's just say it's O of n is linear. So that means that, okay, let's see. So loop has 2 to the n iterations, and each iteration does O of n work. So total complexity, if I could spell it correctly, is equal to O of n times 2 to the n. Okay. And let's kind of show this diameter of a tree, or go through the diameter of a tree to go through the complexity as well, which is that, okay, so this is a set, or this is linear, so O of n so far, you can trust me on this one, because it's just going through the list. And then we have 2 depth first search, so then we have to look at the complexity of the depth first search. And here, you can see that because we never, there's no cycle, and we look at each node at most once, then that means that this is going to be linear, right? Because we look at each node once, so this is linear, and this is linear, and that means this entire thing is linear. But as you know, depth first search, at least in this case, in the worst case, you can have a linked list. So this is going to take O of n space in terms of stack space, right? And it's something that that's pretty much it, because the actual space complexity for us is going to be n. Well, O of y where e is the number of edges because we have an edge list. We have some O of n sprinkled in places, but so O of v plus e is your space complexity. But in this case, note that because this is a tree, e is the number of edges is always going to be vertices. It's going to be vertex minus 1, right? So that means that it's going to be O of v, and that means that the space computer's complexity will be O of v, or linear in the size of the input. Okay, I think now I'm good. Let me know if let me know if you have any questions. Hit the like button, hit all the buttons, and you can watch me solve this live during the virtual contest now. Count subtrees with maximum distance between cities. So usually I refresh to see how many people have solved it, and obviously this is not live, so I'm going to take a quick peek just to kind of see if I could gauge the difficulty of the problem. That would be 9th, but of course this is not a real contest, so there are n numbers from 1 to n, and no one seems to have submitted the Q4 yet, is what I'm just going to say. Anyway, there are n cities, number from 1 to n, you're given an array directional edge from UV, there exists a unique pattern with cities from tree. Okay, so there's a tree, subtree is every city is reachable. Okay, this is usually strongly directed thing, strongly connected component phrasing, but I don't know. When you define subtrees, maximal distance between two cities subtrees equal to d. What? This is very wordy. Okay. You have these edges. I'll put 340. What does that mean? Oh, so for D, 1, 2's maximum distance is 2, 4 is 1, 1, 2, 3. Subtree is 2, which is fair. Oh, it's only 15. Okay, so that's what I'm noticing. Because I was like, this is going to be really hard. But it's only 15, then we can only look at the subtrees. And then you could, basically this is going to be exhaustive. Maybe with DP. This is only 15. And then you just keep track of the arrays. And then just do math on them. Is that even true? So, is it connected? In the diameter of a tree. Okay, I think that's all I got to do. Okay, this is actually not that bad. It's just exhaustive search and the diameter of a tree, which is O of n. So this is going to be O of n times 2 to the n or something like that. Or n squared times 2 to the n. Okay. I have ideas in my head. I'm thinking about implementation. That's what I'm doing now. Yeah, and this is all very interesting. Okay. Let's create an edges first. I still like to make them in an adjacency list. So yeah, so that's what I'm doing now. So maybe that's not necessary. But okay. But now we are going to yeah, okay. So now we just have d is equal to 0 times n minus 1. Okay, and then now we just do the exhaustive search. Yeah, now I wish I was in this contest because I think I would have done really okay. Knock on wood. Okay, so this is mask for is your set for x in range of n if this is greater than 0, subtree at x, and don't really even need it that way. Well, weird, but okay. So then max is equal to, I don't know, go subtree. Like I said, numbering as well. Terrible, but these. Okay, and then that's pretty much it for the framework. Now we just have to get the diameter of the subtree, right? Which is not that difficult in theory. In theory. So what is the diameter? Diameter is just 2 depth first search, so let's do that. How did I get the first number of a set? I always forget. I guess this doesn't have. Does this have to be a set? No, it could be a list. Let's make it a list. And also let's just pass in the mask because I'm being a little bit silly. I know why I wanted it to be a set. Okay, fine. I'm being silly. This is I'm like spending a lot of time doing weird things. And this is how you don't finish top 10 though. Okay, but okay, so now let's do, okay, let's see if, let's also make sure there is at least one element. I was going to add that F3, but okay, so then first is equal to subtree sub 0, and then let's just do a depth first search. I have this written somewhere, but the first, so okay. So basically what we want is we want the furthest node is equal to none. Yeah. And then okay. So that's basically how you would do the diameter. With some really weird bad code, but to be honest, this is like pretty much it. It's just all typing at this point, and I have to kind of figure out how to do the typing part. Non-local first step. Oh, I guess it. Let's do this as 0. Whoops. First step is equal to distance. Furthest is equal to node. Okay. Otherwise, let's go. We wanted to first search for x, or for, let's say we in e sub, or an edges sub node. If we did I do anything with the subtree? Change it back to set. If v is in s, and we, man, I'm a little bit rusty on the tree stuff. Just got back. That's my story, and I'm sticking to it. So if node is, with v is not equal to the parent, and v is in s, then dfs we know distance plus 1. Also have to do non-local and furthest. That seems to be really wrong, so okay. Is this, did I mess it up? Because I think I count 0, and this is actually from 1 to 4, so I have to do something like oof. What can max be? Is it, did I return none? Now it could just be 0 at worst. Huh. Distance is greater than first. What does that mean? The furthest step is more than that? That's not possible. Or maybe I'm just off by 1 on the furthest distance. That's also probably true. Let's just do this then. 0. Yeah, because I start with 0. Okay. So then the first, is that true? I don't know. Let's see. 3, 4, 0. That's not right. Oh, I know. Because I have to check that this is connected. I remember thinking about it, but I forgot. So okay. Okay, I have to see that it's connected. Oh man, we're using variable names. That's why one character up pretty okay. Okay. Visit it. Node. If s is not equal to visited, return -1, and then let's just go if mx is -1, continue. List out range. What? That doesn't. Why? Debugging is so expensive. That's the sad part, is that I know how I've been knowing how to do this. It's just that I'm not doing it. Okay. So C12. Oh, this wants to be 3. No. N and 1, 0, 1. What? What am I doing? And why is this 1 wrong? Why is 1 out of bounds? Am I missing something? Do I reuse the character somewhere? Is that right? This is what I get for jinxing myself. Let's just print D. Why? Why is this? Did I mess up N? N is 2, so we have 1 element away. So that's fair. What am I looking at? The maximum distance between 2 cities, right? And it's 1. Oh, because 0 cannot exist. I'm just really bad at this. Whoops. So this is good. I am dumb. Okay. I don't have to print anymore. Did I remove my print statement? I guess so. Let's give it submit. Only because it's virtual contest. I would probably fit 1 more. Okay, let's go. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join the Discord, and I will see y'all next contest. Bye bye.